1 minimum swaps to make sequences increasing. So let's just check this example. So in this example, nums1 equals to 1, 2, 3, 8, nums2 equals to 5, 6, 7, and 4, and we know that we need to swap with this 8 and 4, and there's going to be only one swap. So after that swap, we're going to have 1, 2, 3, 4, and the nums2 going to become 5, 6, 7, and 8. So we're going to return a 1. And similarly, we can check the example 1. So 1, 3, 5, and 4, we can swap nums1, 3, and nums2, 3. So this 4 gonna swap with this 7, and both arrays will be increasing. Yeah, for this problem, it seems we can solve it by maybe using dynamic programming. So yeah, we just need to find how many different cases. Yeah, so let's just use some examples. So from here, so for example, we have the numbers like 1, 2, 5, and 6. So this is increasing. It is okay. This is for nums1, and for nums2, we have some array like 3, 4, and 3, 4. Definitely, this is not increasing. So what are we gonna do? We can swap 1, 3, 2, and 4 together. So after swap, this will be 3, 4, 5, and 6, and nums2 will be 1, 2, 3, and 4. So this is okay. Yeah. So this is just one case. So this means if this number in nums1 I minus 1 is less than nums1 nums1 I. So for this one, it is nums2 I minus 1 less than nums2 I. It means this index is less than this index. Yeah. So this is one case. If we meet the condition, it means the neighboring two numbers are increasing. This is 1, 2, and this is 3, 4. So this is okay. So what are we gonna do? We can keep it like this, or we can swap all together. This means 1 gonna swap with 3, 2 gonna swap with 4, and after swapping, both arrays gonna be increasing. So this is one case. So another case is for nums1, we are having this array 1, 2, 5, and 6, and for nums2, we are having this array 3, 4, 5, and 6. We can say that this one, nums1 I minus 1, is less than nums1 I, and nums2 I minus 1 is less than nums2 I. Yeah, it means 1 less than 2, 3 less than 4, but we don't need to swap them. Yeah, because even if we swap them, it is okay. This is 3, 4, 5, and 6. This is 1, 2, 5, and 6. It is okay, but we don't need to swap them because for nums1 and nums2 itself are increasing, so it is okay. So how many swaps? It's going to be 0. And for this case, how many swaps? It's going to be 2. So this is just one class. Yeah, so this means this is increasing, and this is increasing, this is increasing, but we can swap all together, or we don't need to swap at all. Yeah, so this is one class. So another class is, let's just use another example. Maybe, so for example, we have 1, 8. This is increasing. Another one is, for example, 3, 2. So this is decreasing. So what are we going to do? We can swap this 1 and 3. So 3, 8, 1, 2, it's going to be increasing. Or we can swap 8, 2. So 1, 2, 3, 8, it's going to be increasing. So do we have this case? So for example, decreasing. So for example, 8, 2, or 4, 3. So nums1 is decreasing. I mean the neighboring two numbers. And nums2 is decreasing, 4 and 3. Do we have this case? We don't have this case. So this means while we are checking for the dynamic programming, we don't need to check this case. It means nums1 is decreasing, nums2 is decreasing. So can we swap it? No, we cannot do that. So for example, 8 and 4, if we swap that, so this is going to be 4, this is going to be 8, both decreasing, it's not possible. Or maybe we want to swap 2 and 3. So this is 2, this is 3, both decreasing. It is not possible, right? Yeah, maybe we have other case. Let's just use a better number. Maybe yeah, maybe let me just use a better example. So this is 8, and this is 3 maybe, and this is gonna be 2, and this is 1. Yeah, this is decreasing, this is decreasing. After swapping, it's gonna be 2, 3, it is increasing, but 8, 1, it is decreasing. It means it is never possible, so we don't have this case. So we only have two classes. So one class is nums1, those two numbers are decreasing, nums2, those two numbers are decreasing. And then we have two different cases. We're gonna swap all together, it's gonna be two swaps, or we will not swap at all, it's gonna be zero swaps. So another case is like this. So nums1 gonna be less, nums1 I minus 1 gonna be less than nums2 I. So this is I, and this is I minus 1. And nums1 I minus 1 gonna be less than nums2 I. Yeah, and then we can swap this one, or we can swap this one. Yes. So what happens if we swap this one? So this is the I minus 1 state. Yeah, and this is the I's state. So now, according to this case, we're gonna define our dp. Yeah. So yeah. So the dp, so for our dp fi, it's always dependent on fi minus 1. Yeah, and we also need to prepare two different cases. We're gonna use 0 and 1. So fi 0, so this means for the ith state, we are not going to swap those two numbers. And if it is 1, it means we are going to swap those two numbers at index I. And similarly for I minus 1, we are also having this state 0 and 1. And according to this kind of definition, we can get the formula from fi minus 1 to fi. Yeah. Now, let's just define this dp and get the formula and to calculate the result. So we're gonna prepare the length of the array. It's gonna be nums1, and let's prepare the dp. It's gonna be to the array. So inside we're gonna prepare the presence. It's gonna be infinity. So for I in raise n, and for the first presence f0, we're gonna prepare two states. So 0 means we don't need to swap, and 1 means we need to swap at index 0. Now we are going to go to the next state. It's going to be 1 to n. So this is from 0. This 0 means we don't need to swap, and 1 means we have a swap. This is why we're going to have a number 1, because one step we're going to count it as 1. Now we are going to check it. So for the first case is nums1 is increasing, nums2 is increasing. So it means nums1 I minus 1 going to be less than nums1 I, and nums2 I minus 1 going to be less than nums2 I. Yeah. If both of them are increasing, as we discussed before, there are two different cases. We can swap all together, or we don't need to swap at all. Yeah. So what happens if we do not need to swap? So it means fi 0, because 0 means we don't need to swap. So it means fi minus 1 to 0. Yeah. So what happens if we need to swap? It means fi 1. This means we need to swap, but we need to swap both of them. Yeah. So it means fi minus 1. This is a 1. It means we're gonna swap. Yeah. And since this one, it means a swap, but we need also to plus another one, because currently for this one we need to have a swap. This is plus another one. So this is previously I minus 1. With this one, it means it has already been a swap, and this is another swap. So for example, this is a swap, it is 1, and this is another one, it is 2. So this means for the next state, if we swap both of them, it means it's gonna plus 2, because here is a 1 plus 1 is gonna be 2. Now we're gonna check the second case. Since the second case can combine with the first case, yeah, because in our example, so for example, if we have some numbers like 1, 2, 3, 4, this is maybe 5, 6, 7, 8, we don't need to swap at all. Yeah. So, but maybe let's just use a better example. Maybe this is Yeah, I can't find a better example. Maybe this is let's say this is 2, 3, 4, 5. Okay, let's just use a better example. Maybe this is 2, 3, 4, 5. This is 1. This is 1, 4, 6, 7. Yeah. So this means we don't need to swap at all. Yeah, but for those two numbers, this is increasing and this is increasing. Yeah, basically we don't need to swap it. If we swap it, it is also okay. So for example, this 2 and 1, if we swap only 1, this is also okay because 1, 3, 2, 4, it is okay. Yeah, and for this one, if we swap 3 and 4, it is also okay because for 1, 4, yeah, because for 1, 3, 2, 4, it is also okay. Yeah, but what happens if there's another case? So for example, this is 2, 4. Maybe we're gonna have 1, 4. Maybe this is a 3, 2. What happens? Yeah. So if this is a 3, 2. Yeah, let's just analyze this. This is 3, 2. This is 1, 4. What's gonna happen? So we just need to swap 3, 1 or 2, 4. Either one of them. We cannot swap both of them because this is another case. Yeah, as we can see that we're gonna swap, it's gonna become 3, 4 and 1, 2. Yeah, but it also includes other cases. So for example, this is 1. Yeah, this is 1. We can also like swap like let it become 1, 4 and 1, 2. It is also okay. Yeah, this is just another case. Yeah, I cannot find a better example. This is yeah, I want to find some increasing examples. Maybe this is a 2, 5. This is yeah, I think this is okay. This is okay. Yeah, this is just one of the examples. We need to include all the cases. Yeah, so let me just continue. So another case is that if nums1 I minus 1 less than nums2 I and nums2 I minus 1 less than nums2 1 I. So we need to include the first case. So fi 0 is going to be the minimum of fi 0. Yeah, because we need to include the first case. It can also happen for the first case. Even we meet the second case, we have to swap them. Yeah, but maybe this is a better one. We are not sure. So for the fi 0, yeah, we will not swap it. If we are not going to swap it, it means fi minus 1. We have to swap fi minus 1. It's going to be a 1. And another case is fi 1. This means we have to swap it. So it's going to be the minimum of fi 1. And for fi minus 1, we don't need to swap it. That is why we're going to have a 0. But we need to plus 1 because fi 1, it means there is a swap. And finally, we need to return the minimum of f minus 1. Yeah, because for the last case, so for example, for the dp at the last place, there are two numbers. Maybe this is 7 and this is 8. Yeah, this means 0. There's no swap for this place. And this 8 means there is a swap, but we're gonna choose the minimum number. It's gonna be this is 7. Now let me just run it. As you can see, it works. Now let me submit it. As you can see, it's pretty fast and it passed all testing cases. And the time complexity gonna be n gonna be 10 to the power 5. I think the difficult part is that we need to find two cases, and those two cases could be combined together. Even though maybe we can find the first cases easily. It's like something like 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so this is for the first case. We don't need to swap. And then maybe we need to find the second case. So for example, it's gonna be 1, 2, 5, 6. Here maybe 3, 4, 3, 4. Yeah. So this means in this case it is okay. We don't need to swap. This is the first case. And for the second case in this one, so it means we have to swap. Otherwise, this is not increasing. We have to swap. After swap, this is gonna become 1, 2, 3, 4, and this is gonna become 3, 4. Here gonna be 5, 6. So this is increasing, and this is also increasing. And there are also other cases. That is the difficult part. Yeah. So for example, we have something like 1, 3, and here 1, 4 maybe. Yeah, maybe we have 1, 4. Here we have 3, 2. So what's gonna happen? We have to swap either one of them. So for example, we're gonna have swap this 1 and 3. Now 1, 2, 3, 4. They are increasing. Or maybe here we're gonna still have this like 3, 4, and maybe here we have like 5, 6. Yeah. So in this case, what are we gonna do? We need to swap either one of them. Yeah. But we are not sure which is gonna be better. So this is why we're gonna use dynamic programming. And sometimes even we are using this dynamic programming, we need also to include the first case, because even though we meet the first condition, but the second case may become a better solution. Yeah, we need to find such an example. Maybe yeah, let's just use an example. Maybe this is a 2, 6, 8, 10. This is a yeah, this is 2. Yeah, currently I cannot find this example. 3. Three, 7, 8, 9. So this is a better example. This is okay. We don't need to swap at all. Yeah, I think maybe. Yeah, let me just use this example. Maybe inside the example 1 or example 2, there's a better case. No, we don't have such case. Yeah, let me just maybe I can find such case. 2, 4, 6, and 8, and another case is 1. 2, 4. Another case is 3. 5. Yeah, I think I need to run it to find another case. So What if let me just run it. So what if I don't need to choose the minimum? Let's check what happens. Yeah, this is not a good example. I cannot find a better example. Yeah, maybe next time. Let me 2 4 6 8 and 3 5 7 9. This is okay, and let me find maybe 4 and 5, and this is 4 and this is 5, but definitely this is not okay. But for 3 and 5 it is increasing, so here we're gonna choose a number like 3. Yeah, let's just use this example. Maybe this is a better example. So we have 2 3 6 8. This is increasing. 3 5 4 5. This is not increasing. Yeah, but what we're gonna do, we can swap just one time to make it work. Basically, we don't need to swap 4 times or 2 times, or maybe we want to swap 2 times. So this is a 2 3 2 3 4 5 from here. Yeah, let me just use another color maybe. So 2 3 4 5 from here, this is okay. 3 5 6 and 8, this is okay. But how many swaps? So there are going to be 2 swaps, but we don't need to do that. Yeah, we just need to make it 1 swap. Yeah, definitely 0 swap is not possible. So what about 1 swap? So what about we swap this 3 and 5? Does that work? So 2 5 6 and 8, 3 3 4 5, it doesn't work. Yeah. What about we swap 2 and 3? It doesn't work. Yeah. So what about we change this number to 4? So this is a 5, but this number gonna be 4. What happens? So 2 4 6 8, it is okay. 3 5 4 5, it is not okay. But what happens if we just swap 4 and 5? It is not okay. But what if we just swap 2 and 3? So this is gonna be 3 2. Those gonna be deleted. So 3 4 6 8 2 5 4 5. It's not okay. Yeah, maybe I can find a better example. Maybe this gonna be 5 and 6. Yeah. Definitely we need to find such cases to analyze why we're gonna use the minimum. So maybe this is a 5 and 6, and this is a 4. Yeah. So this is increasing. This is okay. 2 4 6 and 8. 3 5 5 6. This is not increasing, but what's gonna happen is that we just need one swap. Yeah, even for this case, 2 4 3 5, maybe swap or not swap, but we also meet the second case. Numbers 1 I minus 1, 2 less than 5, 3 less than 4. It is okay. So what we're gonna swap? We just need to swap this 4 and 5. So this gonna become 5, and this gonna become 4. Then it works. So 2 5 6 and 8, 3 4 5 and 6. So this is why we're gonna use the minimum, because it can be combined with the previous case. I think this is gonna be the most difficult part. We just need to find such examples, otherwise we cannot solve it. Yeah. So yeah, let me just resubmit it and prove it works. Yeah, I think that's all about it. Thank you for watching. See you next time.